Hello everyone, in this video we're going to go through 2C, linear coordinate geometry. So looking at just linear graphs basically and applying things like the distance between 2 points formula, which you can see on your screen, the midpoint formula, understanding parallel and perpendicular lines and the gradient of a line. So this topic shouldn't be new to you. You've probably done the distance between 2 points when you did Pythagoras' theorem or as a part of linear and Pythagoras back in year 9, probably saw it again in year 10 and probably again in year 11. So you can see that formula on your screen. It's the distance between 2 points formula, but it's derived from Pythagoras' theorem. So if you remember Pythagoras' theorem, and let's just see if my pen's going to work for me. All right, so Pythagoras' theorem is, excuse me, a squared plus b squared equals c squared. So if I just quickly draw an axis, and I'm going to draw a line, and it doesn't matter what that line really looks like for this example, but on that line we've got 2 points. So I'm going to have one point here and 1 point here. Now those values, it doesn't really matter because I'm just going to label them x1, y1 for our first point, and our second point x2, y2. All right, so I'm just leaning on a pile of books here and it's getting a bit hard to write. Okay, so there's our 2 points. So it doesn't matter what they are, you just substitute those points into the formula. But the way that we get Pythagoras' theorem is if I turn that into a right angle triangle, you've got, as our hypotenuse, that is the distance between the 2 points. Now, if you're wondering how we get the other two sides, the a and b, in our formula, all right, so remember Pythagoras is a squared plus b squared equals c squared. So a and b are your two shorter sides. So your a comes from doing x2, which is this point here, minus x1, which is this point here. So the difference between the two. So that's why you've got x2 minus x1. And then the same for the y's. So this point here is y2, and this point here is y1. So the difference between them is y2 minus y1. So that's where the distance formula comes from. So the good thing is if we can identify the points, it's just a matter of substituting them into a formula. So that's a good thing about formulas. It's just about substitution. Now I did choose a bit of a harder one to do as an example. So for this example, we've got the length of the line segment joining A to 8 and B 12, Y is 26. So we know the length of the line, we know the coordinates of A, and the coordinates of B, we don't know the Y coordinate. So basically that's what the question is asking us to solve. So let's set up our equation. I'm not going to write the formula because doing so would mean the video is going to be a little bit longer, but usually I would write the formula just so you get used to it. All right, so you what I should do is label this. So x1, y1, x2, y2. Now it's not going to matter which one you call x1, y1 and which one you call x2, y2. So even if you end up with a negative number, remember when you square it, it's going to become positive anyway. So don't be too concerned about, well, which one is x1, y1, which one is x2, y2. Doesn't really matter because one way you'll get a positive number, and that's fine because when you square it, you'll get a positive number. Or the other way you'll get a negative number, but when you square a negative, you still get a positive number. So it doesn't really matter. All right, so x2 is 12 minus x1, which is 2, put it brackets, square that, plus y2 is y minus y1, which is 8, and I'm going to put out radical signs or a square root sign. Now just make sure whenever you use a square root sign, it has to go over everything that you're taking the square root of. So don't be sloppy and do something like that because you're in a rush, because what are we taking the square root of? If you think about it, it's probably only going to take that, right? And then this is separate to the square root. So you do got to make sure that your square root sign goes over the whole thing. All right, at this point, I can just use solve on my calculator. You can easily do that by hand, but just for the purposes of this video, I'm just going to use solve on my calculator. And I trust that you can do it by hand. All right, so, oops, just a few matrices there. Let's just scroll down. Solve. Do I want to incorporate? Solve. So we've got, oops, square root. Got my square root sign. 12 minus 2 squared plus y minus 8 squared, and then we're solving for y, so comma y, and I always forget the equals, so that is equal to 26. It will tell me that if I didn't get it. All right, so we've got two values of y here, negative 16 and 32. So if you're wondering which one to choose, oops, my calculator's gone. So you can use either negative 16 or 32, because the way that your the way that your line is, you can go either side. So I'm just going to rub this off. So we've got y equals, what was it, negative 16 and 32. So if I think about this diagram up the top that I drew at the beginning, your point could be on the right side of this point, or it could be on this side. Okay, so probably that's not as accurate as it would be because I haven't drawn the points, but we're looking at a distance of 26, so you could be either side of that A. All right, moving on to the midpoint formula. So the midpoint formula, let me just quickly draw a set of axes and a line. All right, and 2 points on the line. So there and there. And we want the midpoint. So the midpoint is halfway. So that point there. So when you think about this formula, we've got x1, and this one here is going to be x2. All right, so just the x coordinates, and this one's going to be y1, y2. So halfway between x1 and x2, I add them together and divide it by 2 will give me my halfway point. And then the same for your y coordinate. So add y1 and y2 and then divide it by 2 will give you your halfway point. All right, so in this example, we've got points A, B, and C. Find the possible values of A if the length of AB is twice the length of BC. Now I just realized this question you would actually use the distance between 2 points formula, but let's go ahead and do it, and then I'll give you another question with the midpoint, or using the midpoint formula. Sorry, that was me rushing and not really thinking about solving the questions. Okay, so we've got AB, distance AB is twice the length of BC, so 2BC. So what we need to do is work out what the lengths are. So AB, I'm going to use the distance between 2 points formula. So let's just label them x1, y1, x2, y2. Okay, so we're going to have 1 minus 3 squared, and you can see there I'm going to have a negative 2, but remember when you square it, it's going to be positive anyway. And then negative 2 minus a squared, we've got the square root of that. So that's the distance AB. And then BC, we're going to be, because it's twice the length, so I'm going to do 2 times BC. So I'm just going to call this x3, y3. So I'm not going to use x1 and y2 again. So I'm going to call this x3. All right, so 2 minus 1 squared plus 3 minus negative 2, and then the square root of that. All right, so we've got AB there, and then that is equal to 2 times BC. Now you could solve this by hand. All right, so I might just quickly do a few more lines. So negative 2 squared is 4, and then here we're just going to keep that as negative 2 minus a squared. And then let's just tidy this up. So I'm going to have 2 times, this is 1 squared, which is 1, and then 5 squared, so it's going to be 26. Probably didn't need such a long square root sign there. All right, at this point I'm just going to, you could square both sides, so let's go ahead and do that. So let's square. So that just is going to get rid of this squared sign. You're going to square the 2 though. So 4 times 26. And 4 times 26, well, 4 times 25 is 100, so it's going to be 104. All right. I feel like I should keep solving this, so let's keep doing it. So we've got 4 and 104, so that's going to make the right-hand side 100. So then I'm going to be left with negative 2 minus a squared equals 100. And then the squared, I'm going to take the square root of both sides. Now, whenever you take the square root of a number, make sure you do plus or minus. All right, so it's going to be negative 2 minus a equals positive or negative 10. All right, negative a equals, now I might separate them now. 10 plus true, and then negative a equals negative 10 plus 2, so a equals, so that's going to be 12, so negative 12, or a equals, and that's going to be negative 8, so that's going to be positive 8. Now you could solve that quite easily on your calculator just doing this first line here. All right, you don't have to do all that calculation, but it's a good idea to do some things by hand. Don't do everything on your calculator, because a question like this, you're expected to know the skills that I've just shown you to solve that. The thing you need to look out for is whenever you take the square root of something, you do have a positive and a negative. The only time you got to consider, well, am I taking the positive or the negative, is if you've got a restricted domain, or if you're looking at the length of something. So obviously the length can't be negative. Just trying to think what else. When you're dealing with logs, you've got to consider your negatives. Yeah, but in this question here, we've just got 2 values of a. All right, we might fit in a midpoint. So let's do the midpoint underneath. Now, I just might pick 2 points. So let's just do 2 and 10 and 12 and I don't know, 14. Okay, so we're going to label them x1, y1, x2, y2. And all we do is substitute it into the midpoint formula. So remember the midpoint formula here. So we add our x values divided by 2, add our y values divided by 2. And this is a set of coordinates. So it's just a set of coordinates x, y, your midpoint. Okay, so we're going to add our x's. We've got 2 plus 12 divided by 2. And then 10 plus 14 divided by 2. So this is your x coordinate, this is your y coordinate. All right, so 10 plus 12 is 14 divided by 2 is 7. And then 10 plus 14 is 24 divided by 2 is 12. So the midpoint between those 2 points, yeah, is 7, 12. Now, there are more complicated questions than that, but just remember they would be quite similar to the distance formula. So you may be given this point, and I remember doing them. I just wish I had a better one to show you. Anyway, let's move on. All right, gradient of a straight line. So this is what you've been doing for a very long time. So just rise over run. All right, I might not, oh, not run, sorry. Run. I'm not going to go over this formula because I'm going to move on to parallel and perpendicular lines. Now, parallel lines basically mean that the two lines have the same gradient. So if two lines have the same gradient, they're never going to cross. Perpendicular lines cross, and the angle formed by those two lines is a right angle. So when you think about perpendicular lines, a chair leg or a table leg is perpendicular to the floor. All right, so you should be familiar with perpendicular and parallel. So often we use the symbol that to represent parallel and this symbol to represent perpendicular. Now, perpendicular lines, their gradients, you can use this formula here to work out whether they're perpendicular, or to calculate which one, to calculate what the gradient is if it is perpendicular. But basically what you do is you take the negative reciprocal. So if your gradient, what I mean by that is if your gradient of one line was 4, the gradient of the other line, which I'm going to call M2, is the negative reciprocal. So by reciprocal, you just flip it over into a fraction. So M1 is the same as 4 over 1, so its reciprocal is 1 over 4. Let's try another one. So I might just do it in a different colour. So let's say I had negative 3/4. All right, because it's already negative, my other one's got to be positive, and then I just flip. So it's going to be the reciprocal of 3/4 is 4/3. All right, so with perpendicular lines, one gradient is positive, the other one is negative, and they're just the reciprocal of each other. Now, what the -1 means is if I was to multiply 4 times -1/4, I would get -1. If I was to multiply -3/4 by 4/3, all right, that would be -1. All right, so just one thing before we do move on. Okay, so the only time this doesn't run true is if you've got a vertical and a horizontal line, because a vertical line, the gradient is undefined. There is no gradient because it's a vertical line, it's straight, and a horizontal line has a gradient of 0. So obviously they're still perpendicular, but you can't use this formula, okay, because obviously you don't have the gradient for one of the lines, and the other one is 0, and anything multiplied by 0 is going to be 0. All right, I quite liked this example. This is a little bit different. So we're going to, I think, use a distance formula with this, but also our knowledge of perpendicular lines. So in the rectangle A, B, C, D, the points A and B are 4, 2, and 2, 8. Sorry, I should have kept talking. All right, so they're not on my diagram. I might make this a little bit bigger so we can see the diagram. All right, so 4, 2 down here, and B is 2, 8. All right, and the equation of AC, now sometimes I like to write things again, so AC, and just make sure you write it correctly. So I didn't like how I wrote that. Let's try again. So AC, the equation is y equals x minus 2. So AC is this line here. All right, so what we need to do is find the equation of BC. Now, I don't think we can do that without working out the point of C. Let me just quickly think. So we don't know what C is. All right, I did have to have a quick check of what I thought I was doing. So BC, this line here, we know 1 point on that line. So if we think of a straight line, we have y equals mx plus c. So what we need is either 2 points or we need 1 point and a gradient. Now at this point, all we have, let me just get a different colored pen. All we have is the point B, 2, 8. All right, we don't know what the gradient is, and we don't know the value of C. But we can work out, we do know the gradient of AC, but it's not really going to help us too much. So let's work out this line AB, or at least just the gradient of AB. So AB, so my 2 points, 4, 2 and 2, 8. So remember your y's overrun, so just your difference in your y's over the difference in your x, so 2 minus 4. So what's that? 6 over negative 2, so it's going to be negative 3. So the gradient of AB is negative 3, and we can see it's going to be negative because it is a negative gradient. So using your knowledge that perpendicular lines, because BC is perpendicular to AB, that means the gradient of this line is the negative reciprocal of negative 3. So we've already got this one negative, so it's going to be positive, and then the reciprocal of 3 is 1/3. Now usually we wouldn't write plus 1/3, but I just wanted to show you that this one was positive because the other gradient is negative. All right, so we can substitute those values now into this linear equation. You can do it on your calculator. We've got 8 equals 1/3 times 2 plus C. So C is equal to 8 minus 2/3. So what is that? 7 and 1/3. So your equation is going to be y equals 1/3 x plus 7 and 1/3. Now, if you don't like it, or if you don't like it left like that with the thirds, or you know, sometimes you get an exam that asks you to put it in a specific way. Let's just put it in intercept form. So I'm just going to leave that 1/3 x, and 7 and 1/3 as an improper fraction is 22 over 3. So now I can divide both sides by 3, and I get 3y equals x plus 22. And intercept formed, we usually have the x and the y on one side and the constant on the other. So you can write it like this, or intercept form like this. All right, so we've only done part A, the coordinates of C. So to work out the coordinates of C, we've got two equations. We now know the equation of BC, and the coordinates of C, it's just going to be the intersection between the equation for AC. So remember, AC is y equals x minus 2, and BC is, what was it? Y equals 1/3 x plus 7 and 1/3. All right, so you can easily solve them by hand. All right, you can just make them equal each other. So you can go x minus 2 equals 1/3 x plus 7 and 1/3. Or you can solve on your calculator. So I'm just going to give you the answer. All right, so x is equal to 14. And we do need to get the y coordinate. So to get the y coordinate, you can substitute it in to either AC or BC. And when you do that, you get y equals 12. So your coordinate's going to be 14, 12. All right, so now we need the coordinates of D. So there's several ways. I'm just thinking we could get the coordinates of D. We can think of the line going through BD. All right, so to get that line, we know it's going to have, it's perpendicular to that red line. So you can get your gradient that way. And then just do the intercept, get your gradient and then use B to get the equation for BD. And actually, we're still a little bit stuck because we don't have, then you can get the equation. I would probably just find the equation of each one, to be honest. Find AD, find CD. All right, so just using your knowledge of perpendicular and parallel lines, finding AD, CD, or if you wanted to find BD to get the coordinates of D. So I'm just going to give you the coordinates of D, otherwise this is going to be one very long video. All right, so the coordinates of D, 16, 6. You could probably even use a distance formula. I'm just trying to think. All right, part D, the area of rectangle ABCD. So we can work out the length AB just by substituting the point A and point B into the distance between 2 points formula, and that length is the same as CD. All right, so I'm running out of room here. Now for, then you would do the same for BC, getting the length there. All right, so I'm just going to show you the length of each one. So the length of AB is equal to, and then we had BC. All right, so we've got the square root of 40 for AB and BC is the square root of 160. Now if we're doing the area, remember the area of a rectangle is just length times width. So it's going to be square root of 40 times the square root of 160. You could simplify those thirds. So if I was doing this by hand, I would simplify the thirds and then do the multiplication, but I'm just going to do it on the calculator just to save time. So square root of 40 times the square root of 160, and the answer is 80. Now I don't think it's given us units. Units squared, 80 square units. All right, I think this is the last part. So the tangent of the angle of slope. So again, we're using the concept of triangles with linear. So if I just draw a very straight vertical line. All right, I'm going to draw a line there. Now, what we're going to be doing is looking at this angle here. All right, so if I draw a right angle triangle, and I'm going to use my axes to show you that right angle in there. Now remember SOHCAHTOA, that's all we're doing here. Tan theta equals opposite over adjacent. All right, so tan theta, I probably should have written best, is equal to opposite over adjacent. Now if your angle is here, theta, then your adjacent side is the side adjacent to the angle, and this is your opposite side here. So all you need to do is find the length of your opposite and your adjacent sides, and then you can work out your gradient. Okay, so remember your gradient is also rise over run. Oh my God, I wrote rum again. Run. I don't even like rum. Sorry, rise over run. So opposite side is your rise, okay, the difference in your y, and the adjacent side is your run. Now you will see this pop up probably in random spots. So just remember your gradient can be calculated using rise over run, but we can also work out that angle formed by either the axes or a horizontal line and your diagonal line, or your line of your equation, by finding out the opposite and the adjacent side. All right, so let's do these two examples. So we've got -4, 1 and 4, 6. So I'm going to rewrite them. So -4, 1 and 4, 6. And I'm going to label them x1, y1, x2, y2. All right, so your opposite side is going to be the difference between your y values. So we're going to have 6 minus 1, which is 5. And then your adjacent side is the difference in your x values. So we're going to have 4 minus -4. So it's going to be 8. So tan theta, sorry, I should do m, which is your gradient, equals tan theta equals, what is it, 5/8. Okay, so that's our gradient, 5/8. If you want to find the angle, remember we just do inverse tan. Now, in methods, when we do trigonometry, we're mostly going to be using radians, but here we're going to be using degrees because we're just finding the degree of this angle here. So just make sure with your calculator, if I just get the calculator up, you're just changing, yeah, you can see where I'm clicking. So we want it in decimal. So inverse tan, what was it, 5/8. So about 32 degrees. All right, with question B, we've got the points 2, 3, -4, 6. All right, so we're just going to calculate m first using rise over run. So we've got 6 minus 3, so the difference in your y's, over -4 minus 2, the difference in your x's. So we're going to have 3 over, what's that, -6. So simplify, that is -1/2. Now, we've got a negative gradient here. So the previous one was positive. So I'm just going to show you the difference between what angle we're actually looking for with both of them. So in question A, we had a positive gradient, and it doesn't matter what it was if I'm not drawing that correctly. The question actually asked us to, for each of the following, find the angle that the line joining the given points makes with the positive direction of the x-axis. So the angle we're looking for in this one is this angle here. All right, so the positive direction of the x-axis, so that's the positive direction. So we're looking on this side of that line. Now we would then expect to get a gradient that is less than 90 degrees, which we did, I think it was 32. All right, so let's look at B. So in question B, we have a negative gradient. So it's -1/2. So it's going to go down like that. And we still want the angle that it forms with the positive direction. So we want that angle there. So what we expect to happen is for it to be greater than 90. So somewhere between 90 and 180. All right, so this -1/2, you might think, well, I can't have my adjacent side being -6, but that's not really going to matter when you calculate your angle, because we're going to have tan theta equals -1/2. So theta equals inverse tan of -1/2. And then we'll just do that on the calculator. And you can see we get 26.56, and it's actually negative. All right, so that angle that we just worked out, this is why it's probably a good idea to quickly think about, well, is it a negative or positive? The angle is this one here. So that is actually, what was it, 26.6. So this blue angle, when you think about it, just forms a straight angle. So a straight angle is 180. So it's just going to be 180 minus 26.6. So on our calculator, I'm just going to go 180 minus, whoops, sorry, I'm not used to this calculator. All right, scroll down, and we can just have 153.4. So our angle is 153.4. So you do need to consider, well, what is the question asking? Is it asking for this green angle or is it asking for this blue angle? And you should realize also that your angles can't be negative. So when you're dealing with solving the gradient or the angle of the line using a negative gradient, just be aware if your answer is negative or not. Okay, so just be conscious of that. All right, I think that's the end. Awesome. Bye, guys.